My name's Harley, and I'm here to take you through today's algebra lesson.
Hello, swans and falcons. Sorry about that. I had to wrestle the iPad off Harley, and he's really not up to algebra, so it's me again, I'm afraid. Anyway, here's your learning intention for today. Can I substitute numbers for letters in algebraic equations? Pause the video, get that written in your books, and then restart when you're ready to move on. I'd like to start this lesson by recapping on what we learned yesterday about looking at mathematical stories and expressing them as algebraic expressions. So have a look at this question here. It's a SATs question, and pause the video, have a go, and then restart when you're ready to go through the answer. Okay, so we know that there are n counters in Alfie's bag. We don't know how many there are in there, we just know that that number is represented by the letter n. And Alfie puts 3 more counters in the bag. So what expression could we use to show the number of counters that are in the bag now? So at the start we know he had n, and he added in 3 more. He put 3 more in, so he added 3. So there's our algebraic expression for that question. How about this one then? Megan has 2 boxes. There are m counters in each box. She puts all of her counters together in a pile, then removes 5 of them. Write an expression for the number of counters that are in the pile now. Press pause, have a go at this, and then restart when you're ready to go through the answer. Okay, we know she's got m in each box, so she combines them. So she's got m plus m, and then she takes away 5. So you may have had that as your expression, but remember yesterday we looked at writing expressions in their simplest form. How many m's have I got there? I've got 2 lots, haven't I? So I could actually write that as 2m minus 5. How did you find those last 2 questions, recapping from yesterday? Let us know on the blog if you had any problems, and we'll try and help you some more with those. So moving on to today's learning then, we're looking at substituting shapes or letters for numbers. So in this example here we have a square which is equal to 100 and a triangle which is equal to 10. So what would the total be if we had a square plus a triangle? And what would it be if we had a square plus triangle plus triangle plus triangle? Pause the video and have a go at those, and then restart when you're ready to look at the answer. Well, what we need to do is substitute those shapes for numbers. So we have a square here, so we can substitute that for 100, because we know here that a square is equal to 100, plus a triangle which is equal to 10, so plus 10, which equals 110. This second one here we can substitute again, so we have 100 plus 10 plus 10 plus 10 equals, well, I know 3 lots of 10 is 30, plus 100 is 130. Okay, with this example then I'm looking at letters rather than shapes. So I have, if x equals 10, what would 2x be? Now do you remember what we said yesterday? If the number is right next to the letter, that means it's multiplied, so it's 2 lots of x. And this one down here is x squared, so it's x times x. Don't be fooled into thinking that's x times 2. It's not, it's x times itself. Okay, so pause the video, have a go at those, and then restart when you're ready to look at the answer. So 2x is the same as 2 times 10, which equals 20. And then this one here is x squared, it's x times x, so 10 times 10, which equals 100. As you'll see from this example, you might have more than one letter in your algebraic equation. In this example, we have the letter J, which equals 6, and the letter A, which equals 9. And we need to calculate the following. Okay, so remember what I just said about if the number is next to the letter, it's multiplied, so 2 lots of J. And if we think back to our BIDMAS learning that we did earlier in the year, brackets comes first, okay? So because multiplication comes before addition, I needed to put brackets around this to show that I add these 2 first before I multiply the number. Can you remember from yesterday what we said this line means? It means divide, doesn't it? So it's J plus A divided by 5, and the brackets show me that I need to do that addition first. So have a go at those and then restart the video when you're ready to move on. Welcome back. Let's look at the answers together then. So I have 2 lots of J, and I know J equals 6. So I'm doing 2 times 6 plus A, which is 9. Now I don't need brackets for this one because multiplication becomes before addition, That's what I want to do first. So 2 times 6 is 12. 12 plus 9 equals 21. This one here then, I've got to do the brackets first, haven't I? So I've got to do my 6 plus 9 first. So it's going to be 6 times 6 plus 9, which is the same as saying 3 times 15, which is 45. And this last one then, we said that the line there means divide, but I have to do the brackets first, don't I? So first of all, I'm going to do 6 plus 9 divided by 5, which equals 15 divided by 5, which equals 3. Pause the video now, have a go at the worksheet, and then come back to go through some SATs questions together. Welcome back. How did you find the worksheet? Hopefully you found it quite straightforward after watching the video. If there are any problems or things that you really don't understand, please let us know on the blog or via 2 emails so that we can help you with them. Now let's go through some SATs questions together. So n equals 22. The question asks us, what is 2n plus 9? Pause the video, have a go, and then restart when you're ready to go through the answer. Okay, well we know that 2n is 2 times n. So I can rewrite that by substituting 22 for the n. So 2 times 22 plus 9. And I know that I have to do the multiplication first. So 2 times 22 equals 44 plus 9 equals 53. Okay, this one might seem a little bit confusing here because it's asking you to find the value of k. And we're just imagining that k is the total for that number sentence there. So 100 minus 4n is what we're looking to find the answer for. And we know that n equals 60. Okay, so we can substitute n for 60 in this problem. So we have 100 minus 4 times 60. Now with BibMaths, I know that I have to do the multiplication first. So I'm going to do 100 minus, now I know 4 times 6 is 24, so 4 times 60 must be 240. Okay, so 100 take away 240 is going to be minus 140. Okay, well that's the end of today's maths lesson. I hope you got on okay with it. Like I said before, let us know on the blog if you're having any problems and we will help you as best we can. Okay, bye, see you tomorrow.